I'm doing what's known as actually. Let me start out with a brand new between two curves machining. I'll show you how the programming is actually done. So I'm going to use the between two curves machining here. So the first thing you do, you define these two sets of geometry. One is called the drive surface, and then the drive curves. The drive surface in 5-axis mode, as compared to the 3-axis mode, there are two things associated with the cut pattern. In 3-axis, when you said parallel finishing, you would say basically take parallel planes along the X or the Y axis or any angle axis, and then basically slice the model, and then wherever this model is sliced is where you're cutting. You can think of it that way. But in 5-axis mode, apart from the X, Y, Z coordinates that we obtain from slicing, we also have the surface normals we use to actually position the tool along that surface normal. And then obviously there are some additional controls you can use to control the angles and the axes of the tool. To define that, you have to have a surface. So the surface basically gives us not only the coordinate points, X, Y, Z points to position the tool to, but it also gives us the tool axis vectors to use to position the tool. So I'm going to select the surface that I want to machine. So that would be one surface. I'm going to select the other surface, and then I'm going to select that surface as well. So those are, or there's one other surface down at the bottom. So I want to machine all of these surfaces. Okay, once I do that, and then the other important thing is to, in surface normal or surface machining, is you have to define the tool axes, the surface normal, and make sure that they're pointing the correct way. As you can see, the surface normals are all pointing down. So I'm just going to do flip all normals, which allow them to point upwards. And this basically defines your tool axis vectors to say I'm coming from the top to machine rather than coming from the bottom to machine. That's what it does. Okay. All right, and then I've created I've selected these two curves as flow curves machinings. Okay, let's talk about the tool. Very similar tooling is exactly similar to the 3-axis methods that you have. And you can select the wall, flat, corner radius mills, taper with corners. Those are the types of machine tools, cutting tools that you can use in 5-axis. So, and then feeds and speeds, it's very similar to 3-axis. We don't need too many explanations here. Let's talk about clearance plane. The clearance plane is a little bit different in 5-axis. In 3-axis, we just have a planar clearance plane on top of the part like so. But in 5-axis, we have additional controls. You can have a spherical clearance plane for parts that you can approach it from any different direction. And you can also have a cylindrical clearance plane. For instance, if you had a 4-axis type of part, you would use this kind of clearance geometry. I shouldn't call it plane, it's just clearance geometry. But in this particular case, I'm just going to use a flat plane for the clearance geometry. Let's talk a little bit about cut parameters. Cut parameters, you can specify whether you want the output to be in 5-axis mode or in 4-axis mode. We talked a little bit about this. This is only available in the premium configuration that you can drive or create the toolpaths either in 5-axis mode or in 4-axis mode, depending on what your machine tool is capable of. And then cut tolerance, you're familiar with that. Max angle change, these are things that we use to control the accuracy of the toolpath. And then the cut traversal, whether you want the zigzag pattern or the zig pattern. Step over, this is the distance between two paths, very similar to 3-axis. Tool axis control, we can say you want it to be fixed axis. You might want to do it in 3-axis mode, for instance. If you want to do surface machining in 3-axis mode, you can say fixed axis. Select fixed axis and lock the axis to the Z-axis and drive it. You can also specify, otherwise I'm going to leave it unchecked, which means it's going to use the surface normals and do true 5-axis mode. And I'm going to select the 5-axis machine here, configuration here. And then also, these are two important things. You can control you can modify the tool axis by specifying a lead or a lag angle. A lead angle is an angle that is tilts the tool in the direction of the cut. So if you set a lead angle of 10 degrees, it's going to take the surface normal and tilt it along the cut direction by 10 degrees. And a lag is basically a negative angle. And a tilt angle is basically normal to that cut direction. So we can get into that later. And tooltip control, this allows you to move the tooltip in or outwards. If you wanted to do roughing, you can do that with this methods. Cut levels, you can also specify cut levels, similar to Z-axis control or multiple cut levels. Entry exits, I don't want to get too much into the details. Your eyes might glaze over. And let's talk about Gout check. Let me generate this toolpath first. So it's going to run. Okay, there's my toolpath. As you can see, let me go in and change the step over direction. Please type in your questions if you have any questions, and I might be giving you a lot of information here. So I want you to make this as interactive as possible. So I changed the step over direction, step over control amount, which basically controls the distance between two successive cuts. And as you can see, it's a really nice toolpath. But as you can see, these gray surfaces down here are being machined, which we don't want. And the reason this little boss that's sticking out is not machined is because it's not part of the control geometry. I didn't select that as the drive geometry, so it's fine. So how do we avoid these? So that's the other set of control geometry that we have in 5-axis, which we call Gout check geometry or check geometry. So basically we can tell the system that, hey, I want to machine these surfaces, but I want to avoid these surfaces. So basically check against them. So I'm going to add these surfaces as my check surface. I'm going to select them. If it's a poly surface, it's probably easier to select the. Okay, let me select that. Let me, for the sake of, I don't want to select that for now to keep it quick. And then we also have a gout check strategy. So we can leave out the cutting gouging points. We can retract along the tool axis and by a clearance and not machine those surfaces. Let me do this first. If I do that, it's still machining. As you can see, it's avoiding that gout check geometry that I selected. So that's very similar to the way it handles this boss, because I did not select it in the surface geometry to machine. But here we're actually specifying this to be avoided. And the other thing I can do is, instead of doing that, if you don't like the way it picks up over that control geometry, I can go back in there and change my gout check strategy to actually retract along the tool axis. That might give you a better tool path and a lot less vibrations in the tool. So here, basically, we're moving up above that surface and not and avoiding it completely. So those are the two types of, or three types of control geometry, if you will, that we have in 5-axis mode. A little bit different than in 3-axis. So we have the drive surface. Drive surfaces define your cut pattern, not only your cut pattern, but also your tool axis vectors by taking the surface normals from the drive surface. And then you have drive curves, which actually, depending on the way you select it, they define the cut pattern on the tool surface, on the drive surfaces that you've selected. And finally, we have the gout check surfaces or check surfaces that are the surfaces that you want to avoid. So these are the three types of control geometry that we have in 5-axis mode. It's a little bit different than the 3-axis mode. That's why we spent a lot of time trying to make that distinction. Okay, any questions at this point? Don, anything that I need to show, answer?
No, we're all set for now.
Okay, very good. Okay, let's move on. I want to show you this part where we're actually machining a 4-axis part.